49. 1 over 2 plus 2 over 3 plus 3 over 4 plus dot 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 plus 14 over 14 plus 1. Again, they want the sum, the summation notation. Again, my analysis says, well, I think that this should be when I equals 1. If doesn't work, I'll go back. And here when I equals what? What do you think?
Is it I plus 1?
14, right? 1 when I is 1, when I is 2, when I is 3, when I is 14. So from I equals 1 to 14. Definitely from a fraction, because all of them have fractions. What do you think we have in the numerator? Yes. When I is 1, I have 1. When I is 2, I have 2. When I is 3, I have 3. Dot, dot, dot. Finally, when I is 14, I get 14. Excellent. Well done. Now let's look at the denominator. When I is 1, I don't get 1. I get 2. When I is 2, I don't get 2. I get 3. And when I is 14, I get 14 plus 1. So what should I have in the denominator?
I plus 1.
Awesome. Well done, guys. Exactly. Now I can sit here and check. When I is 1, yeah, I get 1 over 2. When I is 2, yes, I get 2 over 3. When I is 3, yes, I get 3 over 4. When I is 14, I get 14 over 14 plus 1. Excellent. Okay, let's choose another. 51. 4 plus 4 squared over 2 plus 4 cubed over 3 plus dot 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 plus 4 to the nth power over n. Same thing, they want us to come up with a summation notation. Again, I make the same assessment. I'm hoping that I'm on the right track. I can adjust later if that's not true. But I'm hoping that this is obtained when I is 1. And then this one, this is I is 2, dot, dot, dot. And this is when I is
4. N.
Very good. So then I'm hoping that from I equals 1 through n. Although this one is not a fraction, I will make it into 1. Because obviously all of them have a fraction. So then, can anyone give us the numerator? When I is 1, we get 4. When I is 2, we get 4 squared. When I is 3, we get 4 cubed. When I is n, we get 4 to the nth power. So what should the numerator be so that it works for all these?
4 to the I.
Very good. Now let's look at the denominator. When I is 1, when I is 2, when I is 3, when I is n. So what should we have in the denominator?
I.
Now we can sit here nicely and check. When I is 1, do I get this? Of course. When I is 2, do I get this? Yes. I get 4 squared over 2. When I is 3, do I get this? Yes. I get 4 to the third at the top and 3 in the denominator. At the end of the class, I'm going to post the previous tests, so please work on it so we can talk about it on Monday. Okay, let's look at what would you like? You want to go back to the recursion formulas? Yes, let's go back to another example like that. Don't you like it? I ask and I answer. Sorry, I didn't mean that. So A1 equals 2. A sub n equals 5 times A sub n minus 1. Of course, for n greater than or equal to 2. The question is asking us to find the first 4 terms. First 4 terms. A1 is clear. Can anyone think about A2 and then A3 and then A4? How much is A2? Or A sub 2? A sub 2 is 5 multiplied by what?
A
Sub.
N
If this
minus
is 2, this is 2 minus 1. If this is 10, this is 9. The previous one,
it's 5 times 2.
5 times 2. So it's 5 from the formula times 2, which is the previous term, 10. A sub 3.
10 times 2.
It's 5, right?
Yes. Oh,
The formula says 5 times the previous term.
so it'd be 5 times 10.
Very good. And A sub 4?
5 times 50.
Excellent. That's it. Let's look at another simplification. Yeah, 41. It's a combo with factorial notation from I equals 1 through 5, from I factorial over I minus 1 factorial. And I lost track of my pages. What am I? I'm on 9. And then 10. Okay. So let's take this aside and try to simplify it if we can. Which of these two is bigger? And that's my starting point. Is it I or is it I minus 1 bigger? I is bigger. Very good. So I will not change I minus 1, but I will change I factorial into I times I minus 1 factorial. I always start with what I have, and the next factor will be the same minus 1. The next one will be this minus 1, and so on and so forth. Look how nice this is going away. So all this is basically the sum from I equals 1 through 5 from I. So when I is 1, I get 1 plus. When I is 2, what do I get?
2.
Very good. Plus, when I is 3, what do I get?
3.
Very good. And plus 4, and then I have to stop at 5. Not a big deal. The 5 plus 5 is 10 and 15. Any questions on this? Any questions? Any questions? Okay, so we have time for one more. Let's look. Any preference? I'll let you choose anything you like. Any preference?
No.
Okay, if no preference, I'm going to choose 30. Is the sum from I equals 1 through 6 from 7I. Yes, we can plug this in the graphing calculator and we'll get the answer in a blink. But I would like to use a property that we discussed, and that is 7 multiplied by I multiplied by a factor. I move the factor in front. And this is the sum from I equals 1. Of course, it's a product to 6 from I. So this will be 7. This is the same thing we did, but now it stops at 6. So all I have to do is just add 15 plus 6. So that's 21. Because I already calculated this till 5. Till 5 I got 15. And I only have to add 6 to it. 147.